Welcome. In this video, I'll be discussing the formula used for standard deviation for ungrouped data in a frequency table. So let's use this example. A set of ungrouped data in a frequency table would look like this. So we have x values, n x values with corresponding frequencies f1 up to fn. So this would mean that the sum of all the items is going to be the addition of fx. So that would be fx1 plus f2x2 plus f3x3 plus, until you complete all of them, fnxn, whereas the total number of items is going to be the addition of all the frequencies. So this is what we called n in the ungrouped data. That would be f1 plus f2 plus until I have all of them. And by definition, mean of the data, which is also called x bar, would be sum of all the items over the total items. So this would be f1 x1 plus f2 x2 plus until fn xn divided by addition of all the frequencies plus fn. So this would mean that our frequency, if I'm to introduce the summation notation, the mean is going to be given by, so this is our x bar, or the mean is going to be given by summation of fx over summation of f. This is the formula that we use to calculate the mean. It's still ungrouped data, but it's from a frequency table. Next, if I'm to calculate the standard deviation, that is the sum of all the deviations from the mean, I would have, so this would be sum of all deviations from the mean are going to be f into x minus x bar squared. So this is f1 and this would be x1 plus, I'll go on f2 into x2 minus x bar squared until I add up all of them until the last one, which is n. So fn xn minus x bar squared. So that's the sum of all the deviations, meaning that the formula for standard deviation in this case would be the square root of summation of f into x minus x bar squared over summation of f. This is the formula that we would use for standard deviation in this case. I could also write this formula in a different way, where both of the terms inside are broken down or separated, and that would be that the standard deviation is going to be square root of summation of fx squared over summation of f minus summation of fx over summation of f and squared. So I can choose to use either this formula or this formula, depending on how I've organized my data. So when we have ungrouped data but organized in a frequency table, we would use this formula for the mean, summation fx over summation f, this formula or this one for the standard deviation.